here it is. Hopefully it doesn't have obnoxious and loud fans, and the voltage displays the correct voltage. This is the cable that came with it. These are the cables that I'm gonna put on instead. And unfortunately, it does still have a tiny little bolt, even though it came with bigger connectors. Oh well, here's the inside. I'm just gonna be honest with you. Look at the size of these terminals. Here's the switch. Here's the 1, 2, 3, 4, 5, 6 coming off the negative. And look at these terminals. They're almost too big to be tightened down. Anyway, I don't really know what I'm looking at here. This is for those of you that are actually interested and know a lot more than me. But that's the inside. There we go. Now it's on. 12.4. Is it correct? 12.6. Ah, you can never win. Now we're going to plug this in. So now we have power to this and the one down there. And we're going to plug this in. And then we're going to plug this in. Make sure it's off. And then we're going to turn her on. There we go. Now fan heat 2. That is so hot. That is almost too hot to keep my fingers on. The fans aren't coming on, even though this is so hot. I think it's that dodgy connection on the inside that's creating all that heat. It's not very hot anywhere else. It's not nearly as hot as that spot there. That is so hot right there. It's almost too hot to hold. This one's not quite as bad as this one. Just remove the inverter. I'm kind of over the fact that the inside of these are so small and dodgily done. So I'm swapping them out for better crimps. So let's open her up. Fortunately, I can't pop this open anymore, but already you can see that the crimps aren't even sitting flush with that piece of metal. That is a big reason why it could be overheating. Look at that. And I remember the red one being a lot hotter than the black. And so we're going to swap them both out for like the right size, but still, that's so bad. This was $300. A couple major things wrong with this is the heat shrink is covering half of the terminal, like the contact point. So we're just going to take them both off, positive and the negative. Oh, and look at that. Look at how it's been crimped. That's not good. Well, I'm glad it's going to be easy to undo it. And that's pretty good. That's not going anywhere. Okay. So I had to remove the fan in order to get the bloody... bolted in, ready to pop the top on. I think it went this way. Make sure we're not catching any wires. So I've just noticed that one of these cables, in fact the switch button, this line, it came loose as I was fiddling, and it attaches down onto that terminal. I really don't want to have to solder that. The good thing is in order to use this remote, you need to have that switch off. So what I'm going to do is just hook it up, and you know, woo, capacitor's charged up. And now for the moment of truth. I'm going to switch it on, and it works without the need for that switch anyway. Ah, that's so good. So I'll just put some electrical tape over that and call it a day. Okay, inverter is installed again. We can do our little test. Look at this mess. Turn it on. Turn it on full. Get amp meter. Now we can turn this on. The inverter's meant to cut out when it gets below 10. So if it doesn't cut out, 9.9. Should have probably cut out by now. Or at least the things aren't heating up. Which is really good news. 10.3. Still at 10.3. 10.2. Cuts out at 10.2 over here. Anyway, so that's cool. These didn't get hot, which is great. Anyway, so that's me done testing and modifying. And I gotta say, the tool that I appreciated most was this fan, which died halfway through. So I need to charge it. It takes like 12 hours to charge. Anyway, so the inverter needs a new test that will hopefully not get these hot. Happy days. Bye.